All right, this is section 6.1, fundamental trig identities. So first of all, part 1 gives us all the different identities we're going to use so far, and there's more, but this is what we're going to start with. So part B, 1b is reciprocal identities, like cotangent x equals 1 over tangent x, and secant x equals 1 over cosine x, and the other ones. The letter C, the quotient identities, which say tangent x is sine x over cosine x, or cotangent x equals cosine over sine. And then the Pythagorean identities, which originate with x squared plus y squared equals r squared. Yeah, x squared plus y squared equals r squared. And then if we divide through by r squared, notice we get cosine squared plus sine squared equals 1. Okay, let me zoom in here so we can see if we're having to write anything. So cosine squared x plus sine squared x equals 1. And then from there, if we were to divide through by cosine squared, I'd have cosine squared over cosine squared is 1 plus sine squared over cosine squared, which is tangent squared x, equals 1 over cosine squared, which is secant squared x. And that's the second one. And if I go back to the first one, cosine squared plus sine squared equals 1, and divide by sine squared, I would get 1 plus cotangent squared equals cosecant squared, okay, which is the third one listed there, okay? And then even and odd identities. Remember, we've seen these before. Remember, cosine and secant, whatever involves only cosine, which is the cosine and the secant, are even, and all the other ones are odd, okay? What does even mean? Well, that means cosine of negative theta is equal to cosine of theta, or secant of negative theta equals secant of theta. And what does odd mean? It means, for example, sine of negative theta equals negative sine theta. So the even ones allow us to remove a negative from the argument, and the odd ones allow us to move the negative out to the coefficient. Okay? All of these identities, by the way, have an equal sign, and really what they allow us to do is replace the left-hand side with the right, or the right-hand side with the left. Okay? Whichever way is beneficial to us at any particular point. All right, so let's see how we're going to use these. Let's start with the examples, part F, example number 1, which is the example says simplify and write the answer with no fractions. So number 1 is simplifying by factoring, and the expression we will simplify is sine cubed x plus sine x cosine squared x. All right, so first they both terms, right, the sine cubed and the sine x cosine squared x have a sine factor of sine. So I'm going to factor out a factor of sine x. When I factor that out of sine cubed x, I keep sine squared x, plus when I factor out of sine x cosine squared x, I get cosine squared x. All right, and then I see that sine squared x plus cosine squared x is there, and that equals 1. Remember from the Pythagorean identities. So this will be equal to sine x times 1, which will be equal to sine x. And so all that big expression simplified to just sine x. Okay, let's skip on over to number 3. We'll leave number 2 for class. Number 3 says we're simplifying by combining. And what we're simplifying is the following: the fraction cosine theta over 1 plus sine theta plus another term tangent theta. Okay, so two terms. The first one's a fraction, cosine theta over 1 plus sine theta. And then the second term is just a plus tangent theta. All right, so first I'm going to say that I'm going to rewrite the tangent theta as sine over cosine. Okay, so this will turn into the fraction. The first one stays cosine theta over 1 plus sine theta, plus now the tangent theta will be sine theta over cosine theta. Okay, so I have two fractions, one with denominator 1 plus cosine theta, the other with denominator cosine theta. So I'll just multiply the two denominators to get a common denominator. So the first fraction will now be, because I'm going to multiply times cosine theta, cosine squared theta over cosine theta times 1 plus sine theta, plus, and the second fraction I'm going to multiply times 1 plus sine theta. So that's sine theta times 1 plus sine theta, which will be sine theta plus sine squared theta, all over cosine theta times 1 plus sine theta. So now I have a common denominator. I'm just going to put my two numerators together. My first numerator is cosine squared theta. My second numerator is sine theta plus sine squared theta. So I'm going to, my numerator in the answer is going to be cosine squared theta plus, and I'm going to write sine squared theta plus sine theta. Okay? So I just switch the order of the second numerator. Over cosine theta times 1 plus sine theta. Okay, that cosine squared theta plus sine squared theta, again, is just 1. So the numerator is now 1 plus sine theta over my denominator is cosine theta times 1 plus sine theta. So I have 1 plus sine theta on top and 1 plus sine theta on bottom. They reduce or they cancel out. And I have 1 over cosine theta, which equals secant of theta. And that's my reduced, my simplified form. All right. So there's a number 4. We'll leave that for class. Let's go on to part 2, verifying trig identity. So some guidelines. Number 1, we work with only one side, usually the less simplified. Number 2, apply fundamental identities, which are the ones we just saw at work. Number 3, if at an impasse, write everything in terms of sine and cosine. And number 4, as a last resort, you can work on both sides to arrive at a common expression. All right. So I'm going to follow them in that order, right? So I'm going to, first of all, look at, start with number 1. It says verify the identity, and number 1 says the fraction sine of negative x cotangent of negative x over cosine x equals 1. So obviously the left-hand side is less simplified. So I'm going to work with the left-hand side. So how do I write it? I'm going to say LHS equals, that means I'm starting with the left-hand side and working with it. And I just repeat the left-hand side. So the left-hand side was the fraction sine of negative x times cotangent of negative x over cosine x. Okay? And that equals, remember the sine and the cotangent are odd. That means I can move those negatives out. So this will be negative sine x times negative cotangent x over cosine x. Okay? So you see I'm multiplying 2 negatives on top. That'll be a positive. Okay? It's sine x times cotangent x, but I'm going to write sine x as sine x, but the cotangent x in the numerator I'm going to write as cosine x over sine x. So I have sine x times cosine x over sine x over the denominator cosine x. Okay, so in the numerator, sine x times cosine x over sine x, the sine x is canceled. I have cosine x over cosine x, which equals 1, which equals the right-hand side. Okay, so notice I start by saying left-hand side is where I'm starting, and I start by stating that I have gotten to the right-hand side, the 1. All right, that was number 1. Skip number 2 for class. And number 3 says verify the following. 1 minus the fraction sine squared t over 1 plus cosine t equals cosine t. Again, obviously the left-hand side is less simplified, so I'll start there. I will say LHS, or left-hand side, equals 1 minus the fraction sine squared t over 1 plus cosine t. Okay, so I'm going to combine the two numbers. So the 1 I will write as 1 plus cosine t over 1 plus cosine t. Minus sine squared t over 1 plus cosine t. Okay, so 1 plus cosine t minus sine squared t, those are the two numerators. I can write as cosine t plus 1 minus sine squared t. Over the common denominator 1 plus cosine t equals, okay, so now I have 1 cosine t plus 1 minus sine squared t, and the 1 minus sine squared t is just cosine squared t. You remember the Pythagorean that said cosine squared plus sine squared equals 1? So 1 minus sine squared is just cosine squared. Okay, so that 1 minus sine squared t will be cosine squared t. So I have cosine t plus cosine squared t over 1 plus cosine t. All right, I can factor out a cosine t from the numerator. So it'll be cosine t times 1 plus cosine t over 1 plus cosine t. 1 plus cosine t is canceled, so I just have cosine t, which is the right-hand side. Okay? All right. That'll be the video for this section. I will leave the number 4 and number 5 identities, and part 3 we will do in class. Part 3, we're just going to replace a variable and simplify. But we'll leave that to do in class. All right. That'll be, this will be one single video for section 6.1. Okay, and this is the end of it.